In this video, we're testing the convergence of the series 4 plus 3 to the n over 2 to the n as n goes from 1 to infinity. Now there are several ways to get this done, and maybe I'll pick like 2 of them for this video. But the first thing I want to do is just do a direct comparison to a geometric series. So what I notice is that 4 plus 3 to the n over 2 to the n, that's greater than 3 to the n over 2 to the n, which I could write as 3 halves to the n. But I know that the series 3 halves to the nth power is divergent. So I'll say, but the sum as n goes from 1 to infinity of 3 halves to the n diverges. And my reasoning there is that it's a geometric series. That means you just keep multiplying by the same factor every time n increases by 1. But we've already showed that a geometric series where the common ratio is greater than 1 is a divergent series. So we just showed that the terms of our series are greater than those of a divergent series. Therefore, our original series, n equals 1 to infinity, 4 plus 3 to the n over 2 to the n, diverges. Now another angle you might take on this proof is to just glance at this original series and go, wait a second, those terms aren't even getting close to 0. So in other words, we can look at the divergence test to prove this thing diverges. If I take the limit as n goes to infinity of 4 plus 3 to the n over 2 to the n, it's a little ambiguous in introductory calculus what tools we're allowed to use, but what I'm going to do is split this up into 2 pieces. So I'm going to write it as a 4 over 2 to the n, which unambiguously goes to 0, plus a 3 to the n over 2 to the n, which is actually our problematic piece. So the limit as n goes to infinity of 4 over 2 to the n is 0, and I'm left with just the limit as n goes to infinity of 3 halves to the nth power. That's a number bigger than 1 being raised to higher and higher exponents. And that piece goes to infinity, and because our terms are not approaching 0, that means the series itself must diverge. If you enjoyed this video, or at least found it useful, check out another one by clicking one of the links on the left, or click the Zach's Lab logo on the right to explore dozens of physics and math playlists. As always, you can leave your questions, comments, and requests in the comments section below, and I'll get back to you within 24 hours. Thanks for watching Zach's Lab, and best of luck on your math and physics journey.